Assistant Professor Urmi Shah from ICT Department of LG Institute of Engineering and Technology. So today we will be discussing upon the digital demodulation chapter, that is unit number 8, which is dealing with digital demodulation techniques. Up till now, we have studied the various demodulation techniques like Amplitude Shift Key, Phase Shift Key, and Frequency Shift Key, that is ASK, FSK, and PSK. Let's move ahead today with the newer types of demodulation techniques, and let's have a small summary about all these demodulation techniques. After this, we are left with our final unit, which will be dealing upon with the spread spectrum analysis, and that we will be discussing in the later sections after this. So let's have a brief introduction of the topics to be covered in today's session. So the topics which we are going to cover in today's session are ASK, FSK, and PSK demodulators, and what are the advantages and disadvantages of digital modulation schemes. Like what are the drawbacks, what are the limitations of these demodulation techniques, that we will be discussing in today's session. So let's move ahead to the following topics. Basically, amplitude shift keying is nothing but variation of amplitude keeping the phase and frequency parameter constant. In ASK, the values are represented by different amplitudes of carrier. So basically, carrier is varied in accordance to the message signal. And in carrier variation, we have amplitude variation keeping frequency and phase parameter constant. Usually, one amplitude is 0, that is, there is a presence and absence of carrier which we are using, and it can lead to susceptible gain changes. The gain of the modulation technique may change because of these amplitude variations. So basically, ASK is not used or preferred much because it is an inefficient technique. Up to 1200 bps, that is nothing but bits per second. Up to 1200 bits per second, it can survive on voice grade lines. It is used for optical fiber applications. So in optical communication, these ASK technique is widely used. Nextly, the other kind of demodulation technique is binary frequency shift key. Basically, the name BFSK, that is the most common form of FSK, is binary frequency shift key. Here, the two binary values are represented by two different frequencies. So basically, here the frequency parameter is changed in accordance to the carrier signal based on the message signal. And here, basically, the amplitude and phase parameter is kept constant. Then FSK is very less susceptible and it is having lesser error compared to ASK. Up to 1200 bps, that is bits per second, it can survive on voice grade line, which is almost similar to ASK. The applications in which FSK is widely used is high frequency radio. Even higher frequencies on lengths are available using coax cable. So everywhere the application of FSK modulation scheme comes. So these are the two different types of demodulation techniques. The another improvised or advanced version of FSK is multiple FSK. In multiple FSK, more than two frequencies are used. More bandwidth efficient and it is more prone to error. Each signaling element represents more than one bit. So this is basically multiple FSK. Nextly, the different type of demodulation technique, the next category comes is PSK. PSK basically stands for phase shift key. The phase of carrier signal is shifted to represent the data. So basically phase parameter of carrier is varied in accordance to the message signal, keeping amplitude and frequency parameter constant. Basically binary PSK has two phases which can represent two binary digits, that is either 0 or either 1. Differential PSK involves phase shifting and this phase shifting is related or relative to previous transmission rather than some reference signal. So this is all about phase shifting. Now coming to the demodulator circuitry. So basically the demodulator circuitry involves or it has presence of the receiver circuitry which is widely used whenever we are retrieving the original message signal. The demodulator determines the amplitude of the received signal and it maps it back to the symbol it represents. In result, thus recovering the original message signal or original data which was transmitted. So basically in ASK signal, as you can see over here, the ASK signal will be given as an input to the rectifier circuitry. Rectifier basically removes the AC ripple content, that is the analog waveform will be filtered into DC waveform, and finally after passing it to low pass filter or band pass filter, the output which will be generated will be demodulated ASK signal. So this is how the demodulator or detector circuitry works. This is the basic role of demodulation circuitry. Firstly, we will have modulation circuit or modulation signal will be given to the rectifier. Rectifier will filter out the AC content and it will further process via filter the demodulated ASK signal. So this is the working of demodulator or detector circuit. Now, we have discussed a lot about what is ASK, what is FSK, what is PSK. Now let's have a short or a detailed description about what are the pros and what are the cons of all this digital demodulation technique. So coming to the first is nothing but amplitude shift key. ASK is having the following pros or following advantages, that is ASK transmitter and receiver are simple to design while ASK needs less bandwidth compared to FSK. The disadvantages of ASK signal are ASK transmission can be easily corrupted by noise. So noise immunity is very low for amplitude shift key demodulation technique. Now what are the applications where this ASK, FSK, PSK are utilized? So basically ASK is used for early telephone modem, then it is used for transmission of digital data over optical fiber. Nextly, let's have the performance analysis of digital to analog modulation scheme. So basically, coming to the point is bandwidth. Bandwidth is a very important requirement whenever you are dealing with a communication parameter or communication technique like ASK, FSK or AM, FM or PM, everywhere bandwidth plays a very important role. If a communication technique can provide us the sufficient amount of bandwidth, then that technique is really better compared to the other techniques. And it is widely preferred in industry and market as well. So, coming to the bandwidth, ASK and PSK bandwidth are directly related to bit rate. FSK bandwidth related to data rate for lower frequencies but to offset of modulated frequencies from carrier at higher frequencies. You can refer the book Stallings for these bandwidth related concept for analog and digital communication system. In the presence of noise, the bit error rate of PSK and QPSK are about 3 decibel, which is superior compared to ASK and FSK. So these are the bandwidth criteria for all the 3 different kinds of technique, that is ASK, FSK and PSK. Now let's come to the different kind of modulation technique, that is pulse code modulation. Basically, if a signal is sampled at regular intervals at a rate higher than twice the highest signal frequency, then the sample contains all the information of the original message signal. So basically, voice data is limited to 4000 Hz and it requires 8000 samples per second. The analog samples which will be taken will be in form of PAM modulation scheme, that is pulse amplitude modulation, and each sample assigned will be of digital value. So this is all about PCM. Basically PCM, which is having a 4-bit system, gives 16 level, 2 raised to the number of bits. 2 raised to 4 will give 16 levels. The quantized output will having the quantizing error or noise, and its approximation means it is possible to recover the original message signal exactly. 8-bit sample gives 256 level and the quality comparable with analog transmission. 8000 samples per second of 8-bit gives 64 kbps speed. So this is how the analysis can be done for pulse code modulation. These are the waveform, or this is the graph which represents the PM value, quantized value and the PCM code value. This is how you can determine via PCM. Nextly, coming to the PCM block diagram. Basically, the PCM block diagram includes input signal as continuous time, continuous amplitude, analog input signal. These input will be further processed to the PAM sampler circuitry. Sampler circuitry will create the discrete samples and the output will be discrete time continuous amplitude signal, which we call as PAM pulses. That will be further processed to the quantizer block. Quantizer block is going to generate the quantized output in form of pulse code modulation. So it is basically going to generate discrete time, discrete amplitude signal, which we call as pulse coded modulation pulses. These output will be further given as an input to the encoder block. Now what is encoder block going to do? Encoder block will have the coding of these signals in form of digital bits. So the final output generated will be in form of digital bit stream. So this is how the PCM or the pulse code modulation circuitry works. So this is the simple block diagram of pulse code modulation. Following are the references for the topics which we have covered today. You can refer these books. Thank you so much for watching this session. In the upcoming session, I will be starting with a newer chapter, that is chapter number 9, that is spread spectrum for modulation or communication techniques. So let's meet in the next session and discuss the chapter number 9. Thank you so much for watching this session. Thank you.